Hi, and thanks for watching another video from weldingtipsandtricks.com. This week's video is about all the different kinds of tungsten electrodes and which one's better and why they make so many different kinds and all that, and I'm really not sure. But we tested them all out as far as their ability to carry amperage. And there's lots of other things you might consider as far as arc starting, stability, and all that kind of stuff. But we tested them on how well they would carry 200 amps, a 332nd electrode. So the first thing we did is sharpen them all evenly. And we started off with a sharp point using a tungsten grinder so they were all consistent. And we use a Miller Dynasty 200DX set at 200 amps. Started off running them on AC. And 200 amps, set the balance at 65 on all of them and 100 hertz on the AC frequency. And just to compare apples and apples, we left it all the same, and then we went through and tested them all on DC at 200 amps after we resharpened them. So let's see what happened. Alright, the first ones we tested, we did this in alphabetical order. So the first one we tested was a ceriated electrode, and again we used 200 amps. Pretty much once we got the arc initiated, pretty much bottomed out the foot pedal, and you can see the little hemorrhoid sticking off the side there, so it didn't really carry amperage all that well, or at least it didn't ball evenly on the end and started to act up a little bit, and the arc started to wander with that knob sticking off the end. Alright, from the ceriated we went to the 1.5% lanthanated. Did a little bit better, but we still got a little uneven ball on the end that melted a little bit more than I would have liked to have seen it. Next, 2% lanthanated. Now this is more like it. 200 amps. Start off with a sharp electrode, barely melted the tip, and it balled evenly. That carried amperage better than, a whole lot better than the first two. Alright, after the 2% lanthanated we went to pure. We're doing this in alphabetical order just to make sure we kept straight. Now, nothing really wrong with pure electrodes other than the fact that I hate them. But a pure electrode at 200 amps balled up like a Tootsie Roll pop on the end. Which if you're welding on 1/4 inch aluminum on a flat surface, that's not a big problem. But trying to weld on an edge or something thin or right next to a bushing you don't want to arc out on, it's a problem to direct the arc when you got a big monkey fist on the end. So pure does not handle the current very well. Old school guys might still like pure. I've never liked it for anything, but that's just me. And I am old school. Alright, after the pure, we went to the good old 2% thoriated, which they say will kill you because of all the radioactivity, as if all the rest of the stuff we weld isn't 10 times as bad for us. But, you know, I can't in good conscience recommend the 2% thoriated. All I can tell you is I still use it. But it does handle the current really well. And then last here, we used the 0.8% zirconiated, which did not handle the current very well at all and did not ball evenly either, and the arc wandered a lot. So again, ceriated, 1.5 lanthanated, 2% lanthanated, pure, 2% thoriated, and zirconiated, 0.8% zirconiated, and those are your results on the tip after we got done welding. First two got nodules on them. The 2% lanthanated held up really well. The pure didn't hold up well at all. The 2% thoriated held up well to the amperage but didn't ball as evenly as the lanthanated did. And the zirconiated just kind of balled crooked and was kind of unstable. Didn't handle the current well. If I'd have been a lower amperage, the pure and the zirconiated probably would have fared a whole lot better. But I'm testing the ability to carry amperage on this test. That's really all. So the 2% lanthanated, clear winner. Clear winner on the AC, set at 100 hertz and 65% electrode negative on the AC balance. Just barely rounded that sharp tip, which is a good thing if you're trying to pinpoint your heat for an edge weld or welding something a little bit thinner than you normally would use a certain size electrode for. So now we went to DC, and for DC we only tested the ceriated, 1.5 lanthanated, 2% lanthanated, and 2% thoriated. These are the only ones really recommended for using on DC. And all I did here is I stayed on the same piece of aluminum, just gave it a blast at 200 amps just to see what it would do to that sharp tip. And I walked all the way through them. The ceriated, 1.5% lanthanated, 2% lanthanated, and 2% thoriated. 1, 2, 3, 4, and then when I got through, We're going to look at the tips, and there's really not a tremendous amount of difference. So all 4 of these would fare really well for welding on DC. Now, I didn't test them 300 arc starts each to test the tip erosion or anything like that with a really extensive test. I just wanted to see how well they carried 200 amps for a 3/32 diameter electrode. So let's get a look at the tips now of these 4 electrodes and see which one of these fared better. As you can see, there's not a whole lot of difference. Most of them maintain their sharp tip. What was kind of surprising was the 2% thoriated melted that sharp tip a little bit more than the rest of them did. So even the ceriated and the 1.5 lanthanated held up a little bit better than the thoriated, and the 2% lanthanated again just fine. The first 3 pretty much no difference. The thoriated actually eroded a little bit, melted the tip a little bit at 200 amps with a shock of 200 amp blast. So anyway, if you wanted a one-purpose electrode welded well on AC and on DC, the 2% lanthanated will hold up. DC applications for all kinds of multi-pass welds, 2% lanthanated is fine, as well as 2% thoriated. Does a good job, always has. If you want to go down to really aircraft and sheet metal thicknesses, or edge welds, or something tedious where you really need a crisp start, the lanthanated or the thoriated works really well, but what really works well on that is just sharpening them to a needle point with a fine sanding disc. You know, they tell you not to sharpen too much of a taper, but for welding razor blade type thicknesses, or even below about 40 thousandths thickness, sharpen it to a needle. Don't put a flat spot on the end on those kind of thicknesses. Just leave a needle point. If you're concerned about dropping a little bit in the weld, just light up on a piece of copper first. For thicker metal, have a taper like this. For your thick 3/8 metal or multi-pass welds, you don't want a needle point. Alright, well, thanks for watching. A lot of you have asked about the t-shirt with the Down and Dirty Hog on them. They are available now at my website. I have a limited quantity, and depending on how many orders I get, I'll order a bunch more. We'll see what happens. I appreciate you watching. Visit weldingtipsandtricks.com.